Let me work on loading the solution. Oh, I just scanned it. I have not posted it up until now. I mean, I still haven't posted it yet, but I will today most likely. No. Trying to open it. There we go. Oh, man. What? Let's try that again. Ah, there we go. Oh, I guess that'll work. So look at problem 1 on your test, and we'll talk about it, okay? That door shuts fast. It'll get you. Did you take the test? Uh-oh. How did you take the test? Why don't I have your test too then? I mean, oh, I have quiz too. Emily, right? Mm-hmm. But well, we can talk more after class. Okay, so for problem 1, what I did was I subtracted the equations to cancel the x, and so then it gives me, 2y minus a minus 5y, which gives me 7y. And then on the other side, I've got, this 5 minus a minus 9, which gives me 14. 7y equals to 14. I divide both sides by 7. I get y equals to 2. And then I have to plug that back into either one of the equations. I plugged it back into the first one. I mean, x is going to be 5 minus 2y, right? And then, so 5 minus 2 times 2 is 5 minus 4, which is 1. I get x equals to 1. So, any questions about this one? No? Problem 2. See if I can. I'd like to not have that toolbar at this top if I can get rid of it. better. All right. So this one, I multiply the top equation by 3 and the bottom equation by 2 so that I could match up the 4 and the 6 at 12, right? So I get 12x equal to 15y. 12x plus 15y is 78, and the second one gives me 12x plus 14y equals 2 times 38 is 76. Again, I subtract the equations, and this time I get y equals to 2. And then if I plug that 2 into either one of these equations, I should get x equals to 4 from it. So, any questions? Okay. All right. Problem 3 has no solution, in the sense that this system of equations is inconsistent. If you multiply the first equation by 2, you get 2x plus 4y equals to 6, right? And then if I subtract the equations, I get 0 equals to 2, which is not possible, right? So this means that this system of equations has no solution. So remember, this is one of the possible things that can happen, right? In fact, my test is missing a case, right? What's the other thing that could have happened? We could have had infinitely many solutions, right? When the two equations are really the same equation in disguise, then any point on the graph of the line that corresponds to the equation is a solution. So I was also missing that case in the test, right? So I think a lot of you need to spend some time on making sure you can find the equation of a line if you're given its graph, or maybe given a couple points, because a lot of people are kind of not quite on the mark here. There's lots of different ways to find the equation of a line. What I did was just to look at like line 1 and notice it's got a y-intercept of 2. And then I found the rise over the run, right? It runs 1, it goes up 2. So that means that the slope of line 1 is 2, right? Line 2, on the other hand, has a y-intercept of like minus 6. And it's going, right, for every 1 it goes over, it goes down 2. So it's got a slope of minus 2. And so y equals mx plus b, slope y-intercept. So I get 2x plus 2. And minus 2x minus 6, those are my two linear equations. Of course, you could rewrite them in this format, which would even be better. But there they are. And then, of course, now I gave you 5 points if you at least put minus 2 is the intersection. So I did give 5 points for that if you have put minus 2 as that point, and that's where they should both be true. Something like that. Yeah, because it was worth 15, so. But I gave you 5 points for that part, probably. And then, of course, we can check if we plug in minus 2 for x and y, both equations hold true there, right? All right, that was problem 4. So again, I would just urge you to practice how to find the equation of a line, either from a graph or from a couple points. Like, a lot of you need to work on that. Maybe not so much the people who are actually here today, but certainly the class as a whole for sure. Anyway, so p of 1, I plug in 1, I get 3 times 1 cubed plus 2 times 1 plus 1. Some people got this wrong because they somehow transferred the cube over to 3. That's not the case here, though. It's 3 times 1 cubed, right? If I wanted 3x parentheses cubed, that's a very different formula, right? Order of operations, got 3x cubed, not the same as 3x cubed. These are very different, all right? They're not equal. So 3x cubed, so I have 3 times 1 cubed plus 2 times 1 plus 1, which gives me 6. And the next one, 3 times minus 1, well, minus 1 cubed is minus 1. And 2 times minus 1 is minus 2. So I got a minus 3, minus 2 plus 1, which gives me a minus 5 plus 1, which of course is minus 4. So a lot of people got this problem wrong. And I think the people who got it, excuse me, I meant to say a lot of people got this problem right. I was trying to say. And that was great. And people who got this wrong, I think you could easily fix your mistake for like when this kind of problem comes up on the final, right? Like I think this is a problem people can get right the next time it happens. I think this is within everyone's grasp how to plug in a number into a formula and like crunch the numbers. We just have to be careful, all right? The fence problem threw a lot of people for a loop. Here's the way I solved it. I said, okay, so if the width is 20 feet longer than the length, that means that W, the width, is equal to L plus 20. And then, of course, we have the length and the length. So the sum of all the lengths of the sides, right, is 65. So that gives me 4L plus 40 equals to 65, which gives me 4L is 25, which gives me that the length is 25 over 4, which is 6.25. And then the width is, well, L plus 20, right, which is 26.25. So there you go, length 6.25 feet, width 26.25 feet. I did have people get this, but most people got this wrong. All right, you're in a very pretty select community of students if you got this right. Like maybe 10% of the students got this right. A lot of people did something that seemed quasi-reasonable, so I gave you like half credit, something like that, you know. I can definitely see people have been studying on this problem, and I just, you know, just didn't happen for you on the test, and that's okay. I mean, obviously, I'd like for everybody to get all the problems right, but, you know. I'm much more concerned if you couldn't find the equations of the line in problem, like in problem 4, not being able to find the equations of these lines to me is a much more serious problem than not being able to solve that word problem, all right? Complete the square. So what did we do? We took half of the linear term, which is 4. So we do x plus 2 quantity squared, but when I do that, I'm adding 4 essentially, right? So I have to subtract 4, which is of course the square of 2. And then I add 6, so here it is, x plus 2 squared plus 2. That's as far as you can go. We can't factor this completely unless we use complex numbers, but I said you didn't have to do that in here, so that's already factored completely, all right? And then I meant to put the same quadratic here and here, but I just accidentally put the same problem as on the quiz, which is probably why I have a lot of people with the right answer here who were pretty lost up here. But then all of a sudden you can solve this one. Now some of you just know the quadratic formula, and that's wonderful, right? It's good, but I showed you how I would have hoped we could have solved the problem by completing the square down here, factoring completely, and then read off the zeros, minus 3 plus root 29, minus 3 minus root 29. But it is good that I think a majority of the class got problem 8 right. That is good. But I wonder how much of that was because I gave you the same problem on the quiz and I let you have a page of notes. Let's hope I'm wrong about that. And people just got it right because they really understood problem 8. Because there definitely will be a problem like problem 8 on the final. Like that is a certainty. There is very likely to be a problem like problem 7 on the final as well. I'm not really telling you anything terribly surprising. It's very likely that there's a problem like any problem on the tests on the final, because the final is built from problems like those that have already appeared on the test. I have to say, I think overall the class is doing very well here. Some people had some problems in spots, but I see a lot of evidence that you guys are a good way of you have a lot of progress. I think overall, I think the class is, like, almost everybody got this one. That was great. So that's actually kind of surprising to me. I thought more people would get this wrong. So that was good. That was good. Now, typical oversights. People maybe forgot that when you get to x squared minus 4 squared or x squared minus 16, you can break that down into x minus 4 times x plus 4. A couple people did that, right? I think I took off 3 if you didn't get to the last step there. This one here, a lot of people got right. Not everybody wrote it as x plus 3 squared, and I'm fine with that. It's good if you recognized it was x plus 3 squared, but a lot of people didn't, and they just wrote that. That was fine with me. I didn't take the points for that at all. Part D. Part D, we had some. I think people kind of guessed on Part D, and sometimes you guessed wrong. If you at least had the x minus 1, I think I gave you half credit. And like some people had like x squared plus 1 over here, but that's not right. It's x squared plus x plus 1. For part E, it's the difference of squares and then again the difference of squares. So you end up with this x minus 2, x plus 2, and then x squared plus 4. I think a lot of people got this one right as well, which is good. Probably the most common error that people who were almost entirely right but just missed one thing would be on this part F. So we factor x to the 4th minus x squared minus 6 to x squared minus 3 times x squared plus 2 like that, right? So you notice we got a minus 3, a plus 2 gives me the minus back. Minus 3 times 2 gives me minus 6 like we like. Now x squared plus 2, end of the road, we can't factor that, right? It's irreducible. But this x squared minus 3 you can look at as the difference of squares, but you got to use the square root of 3. So that's x minus root 3 times x plus root 3, like that. So some people just left it as x squared minus 3, but that's not done. You can, that's a different, that's x squared minus something can be further factored. All right, so I think I took off 3 points out of the 10 if you didn't do that. But I'm sure that if you're such a person, you'll probably get it right the next time it comes up. So, and that's it. So any questions? All right. Well, with that, let me put this away, and let's get straight into our Chapter 5 exercise sheet. Now, I've handed it to you guys in class because you're here, but of course, some of us are away in quarantine. Others of us just can't get back to class at the moment for various reasons, and that's okay. So let me just give a quick reminder. Laws of algebra, right? Let's just try to make a laundry list of some things we know. One thing we know, if we have like a over b times c over d, the way that works is we just multiply the numerators, right? One thing we have is that, right? If we have, on the other hand, a over b divided by c over d, then we can also express that as a compound fraction, right? And that is nothing more than AD times BC, over BC, right? Alternatively, you could do this. A over B divided by C over D is what? It's A over B times D over C, right? So we can convert division to multiplication by the reciprocal. Okay, this is an important idea. We also have laws of exponents, right? And how do those go? They still matter, right? So like a to the s times a to the t is a to the s plus t. 1 over a to the s is equal to a to the minus s. A to the s over, a to the t is equal to a to the s minus t, right? Is there any other important law of exponents you can think of I should remind us about? What if we have a to the s raised to the t power? That's what? That's a to the s times t, right? So those are, important laws of exponents. We've also done stuff with like root functions, right? Like, the square root is the half power and things like that. Those things will matter for the final, but they're not so much an issue for Chapter 5 at the moment. Chapter 5 is focused on what are called rational expressions. Rational expressions are formed from addition, subtraction, multiplication, division, but not so much, in fact, not really roots. There's no roots in Chapter 5 as far as I know. So we'll come back to roots eventually, but not at the moment. And then, of course, we have to talk about adding fractions, right? How do we add fractions? If I have a over b plus c over d, how do you add that? You can use the cross multiplication rule, right? This is AD plus BC over B times D. In other words, what I'm saying there is you can make a common denominator by multiplying. Now we'll dig further into adding fractions as we get into examples here, but that's kind of like my lazy go-to way of doing it. I just multiply the first fraction by the denominator of the second, and I multiply the second fraction by the denominator of the first, right? And speaking of the numerators, and that's a way of adding fractions, right? Here, to give you some numbers, if I take a third, well, 2/3 plus, 7/5, I can do 2 times 5 plus 7 times 3 over 15. Whatever that is, 10 plus 21, 31/15. You're like, well, I could figure that out on my calculator. Granted, but we're also going to do this with polynomials, all right? Like we're going to look at stuff like, 2 over x minus 1 plus 7 over x plus 2. And the way we add those is the same that we add the numbers above, right? We use this cross multiplication trick to add those. So this is like 2 times x plus 2 plus 7 times x minus 1. And then downstairs I have x minus 1 times x plus 2. Now in this kind of problem, I would typically give you instructions like add the rational expressions, and simplify. Now have we simplified yet? I'll write it down. Instructions at the moment. Now add these rational expressions. And simplify. I would say at this point we've added them. how would you simplify that? I would just distribute, right? Like that's 2x plus 4 plus 7x minus 7 divided by x minus 1 times x plus 2, which is 9x minus 3 over x minus 1 times x plus 2. Could you guys give me any advice on how I could perhaps further simplify that? Something nice I could do here. Now, for the record, I'd give full credit for that. If I asked you to simplify this and you gave me that as an answer, I'd be like, great. But I'd be even happier if you did the following thing, which is to pull out a 3, right? Well, you can either pull out a 3 or pull out a 9. I don't know. What do you guys want to do? Pull out 3 or pull out 9? 9. So like in the next course, when you look at the problem of graphing rational functions, you know, in the pre-calculus course, this kind of thing is super nice because you can then like see immediately like where the x-intercept is and stuff like that from that formula. But anyway, you know. All right. So there is a pretty quick, overview of the kind of things we're about to start doing. And here is a set of problems. I suggest we just start carving our way through these problems one at a time. Actually, a couple at a time. So what I ask you guys to do is, take a look at exercise 1 and think about it for about a half minute. Then I'll ask you what you can, if you can tell me the answer to that. So the question is, find all numbers for which the rational expression is not defined. And the rational expression in play here is (5b squared minus 16 divided by 14b plus 29. And I'll go ahead and write exercise 2 up here while I'm at it. So you have f of x equal to 2x minus 3 over x plus 5, and you're asked to say, it says find the domain of f and express in 2 ways, right? In the 2 ways we're going to express it, either be set builder or what? The interval notation, right? So somebody want to tell me the answer to exercise 1? And so b equals to negative 29 over 14 is not allowed, right? Why? Because this, how did you find that? You found that from saying 14b plus 29 equals to 0, right? That's the bad. If we have that, then we have division by 0, so the expression is not defined, right? And so, yeah, we get 14b equals to minus 29, and then we divide it by 14 to get b equals to minus 29 over 14. So that's why it's Maya, right? That's why Maya told me that. How about exercise 2? So we need x plus 5 is not equal to 0 is what we want, right? We cannot have x plus 5 be 0. So, yeah, x not equal to minus 5. Now, but the question asks us to write it in set builder notation, right? To express the domain. So you're talking about 3/2? Oh, you did number 3. Okay, cool. So the domain of f here. So let me start out here. What's the set builder notation? Domain of f x such that what? What's the condition? The condition is x not equal to 5, right? Minus 5, rather. So this is called set builder. Set builder notation. You put the points in the set and then the condition after the bar. Some people, instead of using a bar, they'll use like a colon here. Either bar or colon. Either way, this is read such that. All right. So I would be fine with either, obviously. It's just the two popular notations for that. Now, how about if I used interval notation? What would the domain of f look like? I think it's helpful to draw a number line, right? And, here's that minus 5, right? So the number line is basically got two pieces, right? You have this piece over here, right? And you have this piece over here, right? So to the left, that interval is minus infinity to minus 5. And then to the right, we have minus 5 to positive infinity. And we need to put those together. So to do those, we use what's called the union, right? Which is just a big U for union. There you go. That would be the domain in interval notation. Oh, so you did number 3, and you told me that for number 3, you wanted x not equal to what? Negative 13 over 5 for number 3. Does that make sense, you guys? For number 3, we want x not equal to minus 13 over 5. So Maya got that from setting the denominator equal to 0 in exercise 3. Let's look at exercise 4. Unfortunately, there are really not many exercises in Chapter 5 on laws of exponents, and I say that's unfortunate because from what I remember, that was a real weak spot in here on Test 1, and that was one of the things that I would really encourage you to go back and try to really pin down before the final, because there will, I'm sure, be a law of exponents question on the final. You know what I mean? I'll give you an example. Something like x to the 7th times x minus 1 to the 10th over, x minus 1 squared times x cubed. Simplify this. This one is, so the way, what you do is basically think of, look for common factors, right? Here there's a common factors of what? Say again, Maya? You say x and what else? Yeah, x and x minus 1, right? But yeah, the one, so oh, okay. So I'm about to say something that I can't say because that's something I would say in pre-calculus. I have to stop myself, Okay, so what do we got? As a general point of order, I try to leave the expression so that the exponents are positive. So I'm going to bring the one that is smaller to wherever the one that's larger, so to speak. So this x to the 7th, I go x to the 7 minus 3, and, oh, I guess they're both bigger on the top, aren't they? So x to the 7 minus 3, come on, times x minus 1 to the 10 minus 2. So this one, we'd have x to the 4th times x minus 1 to the 8th. So that would be a simplification of that rational expression. So all I'm complaining is I don't think there's enough examples like this in your chapter 5. There's like a couple, but there could be a lot more. Because in my experience, this kind of pattern in simplification comes up very, very often in math that follows this. So it would be healthier if you guys have more examples. I'll do another. So x plus 2 to the 4th power times x plus 1 to the 3rd power divided by x plus 2 to the 6th power times x plus 1. Right? Or how about this? X, instead of x plus 1 down here, x minus 1. All right. So one of the important things to learn is not just what you can do, but what you can't do, right? And essentially, having an x plus 1 up here and having an x minus 1 down here, it would be the numerical equivalent of having something like 3 to the 4th power over 3 to the 6th power times 5 divided by 7. Like the 5 and the 7, there's nothing nice that you can do to cancel them. They're just apples and oranges, right? And the same with x plus 1 and x minus 1. Like you can't cancel those or do anything very, very neat. They just kind of sit there. So all we can really work on is the sort of the common factor, which in this case is x plus 2. And we get x plus 1 cubed over x plus 2 to the 6 minus 4 times x minus 1. I decided to bring the numerator factor into the denominator because I saw that the x plus 2 to the 6th was a larger power, and I'm trying to rewrite in terms of positive exponents at the moment. So my goal is an expression with positive exponents, and so now I've got it. There you go. That's as far as we can go. Right. Now, if you had more special instructions like simplify this and expand, right? Expand the denominator in the numerator. Well, then this wouldn't be quite the right answer, right? If I was also told to expand the, polynomial in the numerator and expand the polynomial in the denominator, then I should do what? I should like multiply the things out, right? The instructions, so if the instructions were like as follows, leave the answer as a rational expression formed by ratio of polynomials in standard form, if that was the instruction which was given, then we wouldn't be done, right? We would have more work to do. We would need to multiply out the numerator and the denominator, right? So relative to these instructions, let me give this a name, Pac-Man, there. Pac-Man is, well, what's x plus 1 cubed? It's x cubed plus 3x squared plus 3x plus 1, using that, well, I don't know what you want to say, but now, I mean, you can write that out. What's x plus 2 squared? It's x squared plus 4x plus 4, right? I'm still not done, right? I still have to multiply out that pesky denominator. And so I've got x cubed plus 3x squared plus 3x plus 1. Downstairs I've got x cubed plus 4x squared plus 4x minus x squared minus 4x minus 4. How did I multiply? I used the distributive property. X times x squared plus 4x plus 4 gave me what I'm about to underline in red. Right? And the minus 1 times what, this minus 1 times that gave me all this. Right? And I'm still not done, right? Because I'm supposed to write the answer as the ratio of polynomials in standard form. Are the polynomials in standard form yet? Well, the numerator is, right? X cubed plus 3x squared plus 3x plus 1. That's in standard form. But what about the denominator? Exactly. We had to combine. We had to collect like powers. And once we've done that, we're good to go. Oh, isn't that cool? The 4x and the minus 4x, they cancel out, don't they? And we just got a minus 4. Huh, cool. And so there you go. That would be subject to that example. So, but if I just say simplify, I don't expect you to write it as a ratio of polynomials in their standard form, right? Like if I say simplify the expression, what I want you to do is to make a non-trivial algebraic step, put them together, and just leave it as neat and tidy as you can without, spinning your wheels and doing more stuff, If the instructions are more specific, like this, then you need to try to follow the instructions, right? But by the way, I think this is, in a nutshell, why simplifying expression questions are much more challenging than solve equation problems. Like if somebody says, solve this equation, we can all pretty much agree on what that means, right? When somebody says simplify an expression, there's a lot of room for interpretation there, generally speaking, in mathematics. All right, let's look at another example. So this exercise 5, I guess I'm supposed to do exercise 4 first. So let's do exercise 4 and exercise 5. 4 was r minus 3 over r plus 6. We're supposed to multiply that. Parentheses added by me, right? Times r plus 2 over r plus 2. And down here, I'm supposed to take 9x to the 11th power and divide by 24 x to the 12th power. Let's try to simplify that into an expression with positive exponents as best as we can. Now here it really depends on the instructions to the problem. Like if I just said this on a test and I said simplify, reduce the expression or something like that, then the natural thing to do would be what? Just cancel r plus 2 over r plus 2, right? It's the same factor, But the instructions where this came from in your homework said multiply it out and simplify, I think, or don't simplify. Or anyway, I'll just tell you guys, I'm a little bit frustrated with what's available in the homework in this section, in this chapter. But anyway, so here's what we do. We multiply the numerators and multiply the denominators. And let's hold ourselves subject to what I put into quotes here. Leave the answer as a rational expression formed by a ratio of polynomials in standard form. If I say that, we're not done yet, right? What do we need to do? Multiply it out, right? What do you get? Oh, did I ever? I don't know if I ever. You fixed it? Did it zoom out though?
Oh, yeah.
Oh no. It's not your fault. It's my fault. It should have probably been okay. Sorry to the people not here. If it wasn't, my apologies. Maybe I'll just tell them to watch tomorrow's class. We got what, r squared plus 6r plus 2r plus 12, right? How does that all simplify down? R squared minus r? Yeah, see that one's a minus 3, but the other one's a plus 2, right? In contrast, downstairs we add the 6 and the 2 and get 8, right? So there you go. That would be that. How about exercise 5? Can you guys tell me what to do there? I'll write it out this way. This is 3 times 3 over 3 times 8 times x to the what, 12 minus 11. So we can cancel 3's, right? And that leaves us 3 over 8 x to the what? X to the 1, right? Oh, you said, somebody said x to the minus 1, right? So, I mean, that's not wrong. You could also write this 3/8 x to the minus 1. And so, you know, in the absence of other instructions, I would take either one of these as a correct answer, right? If I said, leave your answer as an expression using positive exponents, then one of those is right and one of those is wrong, right? If I say use positive exponents, which one would be right? Yeah, the first one, right? Okay. All right, so we spent a lot of time factoring, right? So now we're going to use all that factoring stuff in what we're doing now, all right? So a lot of the problems here and what follows in the exercise sheet, they basically boil down to factor what you're given and then try to identify common factors and cancel them out, like we've been doing with numbers or here the factors were already given to us, right? There was no factoring that needed to be done to start with. But in the problems we're about to look at, we actually have to factor before we can make these kind of simplifications. So let's look at one. Exercise 6. So here we have x squared minus 49 divided by x squared minus 14x plus 49. And we're asked to simplify. What should we do? I'll do the easy part. I'll factor the top, right? The numerator is x minus 7 times x plus 7, right? Oh, the down is x plus 7 times x plus 7? Wonderful. So how can we simplify this expression? So here's the sentence I would likely give you in this problem. I'd say something like simplify the expression by canceling any common factors. Maybe I'd say something like that in the instructions. Get rid of the x plus 7, right? These cancel out. And that leaves us with what? Right? And that's it. So if you're 100% solid on your factoring, right? If your factoring is like ironclad, this stuff becomes just a natural extension of what we've already done. Now, if you're not super solid on your factoring, well, this is a great time to get better at it because we're going to keep needing to practice our factoring here also, right? So x cubed minus a cubed over x minus a squared. I'll do the easy part. I'll do the denominator. Can you guys tell me what I should do for the numerator on this example 7? Mm-hmm. X squared. I mean, there is an x squared in there. I'll agree. X minus a, uh-huh. Well, once you got that x minus a there, let's think through it. X squared. Mm-hmm. There's got to be a plus a squared over here, right? Because I have to have like a times minus a. Give me back the minus a cubed. Yeah, plus xa or ax, yep. But yeah, this is by that, remember the special form trinomial? Yeah, we got that a cubed minus b cubed is a minus b times a squared plus ab plus b squared. And then I'm just thinking a equal to x and b equal to, well, a in this case. That's the pattern. So can we simplify anything? Right, the x minus a, and we're just left with x squared plus ax plus a squared divided by x plus a. And that's it. That's all you can do. Exercise 8 says simplify z cubed over 3z plus 12 times 9z plus 36 divided by 9z to the 5th. So I'm going to show you an idea here, which is it pays to do some like factoring before we do the multiplication. And what I mean by that is we can rewrite that as z cubed over 3 times z plus 4. And that is really, 9 times z plus 4 right? Like, yes, we could just, forge ahead and multiply the denominators and multiply the numerators, right? But we make our life easier if we try to understand the fractions before we multiply them. See, like there's a 9 common to the second one, and there's a 3 in the first one. So I mean, oh, look at that. Can you see what? Ooh, look. Oh man, there's all kinds of stuff. Now I can see stuff. You see that? Like these 9s cancel, right? But what else cancels? The z plus 4 cancels. We still got a 3, right? But the answer (1 over 3z) what? I mean, I can do another step. Let me do another step. That's z cubed over z to the 5th, right? But and that we can reduce that further, right? That's what? One over what? 1 over 3z squared, right? All right. Exercise 9. We've got y squared minus 25 over 4y plus 24 multiplied by y plus 6 divided by y minus 5. So here's how I'd approach this. Can you guys tell me what I should do with the first fraction? Uh-huh. Times what? Times, right, that is the y squared minus 25, right? Now I still got this y plus 6 from the other one. And then downstairs, I can factor 4 out of that first one, can't I? That's 4 times what? 4 times y plus 6, right? So it's important to factor the 4 out, otherwise you might not see the fact that this guy and that guy will cancel out, right? And this one will also cancel out. And what are we left with? We're left with y plus 5 oh yeah, just over 4, right? There you go. Exercise 10. We've got 50